Now, because H2CO3 is stable, just like this compound here, it's going to decompose. Okay, so our next line that we would have is we'd have HCl plus our sodium carbonate. Okay, so we're going to still make our salt, our NaCl. Now this here is going to decompose once again into carbon dioxide and water. Okay, and that's what we would have here. Once again, these two just come from this reaction there. Okay, now once again, you need to make sure that you always have your states. You need to always make sure that you balance. Okay, but once again, we're just going through the mechanism so you can see it in action here. Okay, the last one that we're going to take a look at real quick for production of gas happens when we have this here. Okay, so the fourth one for our production of gas. Now, this one is ammonium hydroxide. So NH4 is ammonium, and we have hydroxide, which is OH. Now, this is going to decompose. Same as the other ones. It's unstable. It doesn't like staying as is. So it's going to decompose into water, and it's going to decompose into ammonia gas, which is NH3. Okay, so let's go through another example here. So we have, let's say we had NaOH, and we had ammonium chloride. Okay, so once again, we'll have a double displacement reaction. I know this because we have two things here, sodium and hydroxide, ammonium and chloride. Two things and two things are going to switch. Okay, so the two positives are going to switch. So the sodium and the ammonium will switch spots. And when we get that, we get our sodium chloride. And we would get our ammonium hydroxide. Okay, now, once again, how am I getting this? You need to remember your charges. Sodium and chlorine both have a 1 charge, so they cancel out. Ammonium and hydroxide are both on your polyatomic ion sheet. Ammonium is a 1+, hydroxide is a 1-. So that's why there's no coefficients or brackets or anything like that. So, once again, same idea as the last reactions. Once you see this compound right here, okay, you should be thinking that this will be decomposing. Once again, this also is an aqueous compound. Okay, so most grade 11s or grade 12s, once they see that there's two aqueous here, they'll just stop. They'll say, oh, there's no reaction. However, something they need to remember is if you see this here, it decomposes. So we would get NaOH, ammonium chloride, sodium chloride, and this here would decompose into water and ammonia gas. Okay, so once again, just a couple things before we keep moving on. Both of these states you can figure out by using your polyatomic ion sheet, so I'm not too worried about that. I wanted to just show you these ones here. Okay, once again, obviously you need to balance. Another question that I typically get from a lot of students is, does it matter which order you put this in? So for example, I have my sodium chloride first. Could I have switched these two spots? Well, of course you can. It's just like math, right? 2 plus 3 and 3 plus 2 still give you 5, right? So same idea with chemical equations. It doesn't matter what order you put them in. You just need to make sure that it is correct. Okay, so that is our last example of a production of gas. So at this point, just to kind of recap, okay, we have two reactants making two products. That's our double displacement reaction. Okay, we don't really worry about what our states of our reactants are, but we definitely do for our product. So if we have two aqueuses, we get no reaction. If we get an aqueous and a solid, we would have a reaction. We call that a precipitate. If we get an aqueous and a gas, we call this a production of gas. We just looked at 4 different ones. Okay. And then the last one that we're going to look at right now is what we call a neutralization reaction. And that's when we're going to make an aqueous as well as a liquid. Okay, so let's go back to our lesson. Okay, and if you flip through, the next slide that we should be at here is neutralization reactions. Okay, now before we get into the actual reaction mechanism, we just need to kind of remember what it is. So neutralization reaction is a reaction that happens when a base and an acid get mixed. And the typical reason why we're doing that is because we're trying to neutralize one or the other. So if there's like an acid spill, typically we'll put a base on it to neutralize it. Or if somebody has heartburn, and heartburn is your stomach acid creeping up through the esophagus. So that would give people discomfort. So what people will do is they'll either have some Pepto-Bismol or some Tums. And what that is, that's actually a base. So it neutralizes that stomach acid and it gives people a soothing sensation. So once again, going back to more of a chemistry point of view, remembering, you need to remember your pH scale. So your pH scale, pH stands for the power of hydrogen, goes from 0 to 14. Okay, 0 to 7 is what we call anything that's acidic. Anything higher than 7, so 7.1, all the way to 14 is what we call something being a base. And if you had something that has a pH of 7 exactly, that's what we call neutral. Okay, so pure water, so distilled water would have a pH of exactly 7. Okay, now if we're taking a look at now our reactions here, okay, we're going to be looking at two types of neutralization reactions. The first one has to deal with a hydroxide base. Okay, now when we have a hydroxide base, so for example, we have NaOH, sodium hydroxide, that's a hydroxide base, plus any acid. So the easiest one to typically do is HCl. Well, we're always going to be making water, and we're always going to be making some other ionic compound, which we call a salt. Okay, now in this example, NaCl is typically your table salt, but it's not always it's not always NaCl. Anything else that's left over, that's what we call a salt. It's typically an ionic compound. Okay, so let's do an example of the first one, and we'll go back and take a look at the second one. Okay, so what we're going to do is we're going to look at example 1 here. Okay, so this here is a hydroxide base, calcium hydroxide, and we have nitric acid. Okay, so what I would like you to do is to pause the video, see if you can come up with this double displacement reaction. And once again, more specifically, it's a neutralization. Okay, so pause the video and see if you can come up with it. Once you're done, unpause it, and we'll see if you got it right. Okay, so hopefully you tried it out. Okay, so we're going to go through this here. So first we have calcium hydroxide. Okay, so calcium is a 2+, hydroxide is a 1-. So when we do our crisscross, we get Ca bracket OH2. Okay, next we have nitric acid. So nitric means that it's the normal atom. So normal is nitrate, which is NO3, 1-. So because it's an acid, we need to add hydrogens. How many hydrogens? Well, because it's only 1 here, we can add 1 there. So we get HNO3. Okay. So now we have our crisscross. So we will have calcium and nitrate coming together. So once again, calcium is a 2+, nitrate is a 1-. So we would write it as Ca bracket NO3, close that bracket with a 2 there. And lastly, what would we have left over? Well, we have hydroxide and we'd have hydrogen. So typically we would have 1-, 1+. So sometimes you might actually see people write this as HOH, okay? But once again, more commonly, we would write that as H2O, which is water. Okay, so next we need to make sure that we have our proper states. Okay, so that's where we go with our table here, our solubility rules. So calcium hydroxide, okay, has low solubility, so this would be a solid at room temperature. Nitric acid, because it is an acid, okay, it's aqueous. Also, if you just take a look at nitrate, okay, most of them are soluble, so it should be aqueous as well. Okay, then we have calcium nitrate. So once again, nitrate, most of them are soluble, so we'd get aqueous here. And lastly, we have H2O. H2O would be, obviously, a liquid. So as you can see right here, this is a neutralization with a hydroxide base, where we have calcium hydroxide and nitric acid, and we make our calcium nitrate and water. Okay, this here is what we call our salt. And the reason why we call this a salt is because this is an ionic compound that is formed from a neutralization reaction. Okay, so we have our salt and we have our water there. Okay, so that's the first main type of our neutralization reaction. Okay, so this is the one that you would have seen last year. Okay, now the second type is when we have a carbonate base. Okay, now carbonate is CO3 2 negative. So if you see a compound, okay, that has a carbonate base and it's mixing with an acid, this is what we get here. Now it's very similar, okay, to the one above. Okay, so once again, we'll have our acid, we'll have a carbonate base instead of a hydroxide base. We're going to make water, we're going to make our salt, and we're also going to be making carbon dioxide. Okay, now this reaction here, we actually looked at in our production of gas. Okay, so this is where we make a carbonic acid. But once again, we're going to go through this example or our second example, and you'll see exactly what I'm talking about. Okay, so let's flip the page and let's look at our second reaction over here. Okay, so it says, write the balanced equation for the reaction of hydrochloric acid and calcium carbonate. So we have our acid, we have a carbonate base. These two are mixing together and we're making something here. So what I want you guys to do, just like before, pause the video, try it out, okay? If you get confused, that's fine. Just resume the video and then you can see the answer here, okay? So take a second and see if you can try that second example there. Okay, so hopefully you tried that. Okay, so what we're going to be doing right here is we're going to go through this example. Okay, so this example, okay, I'm just going to go like that. We're working at the bottom here, is hydrochloric acid. So once again, hydro means that there's no oxygen. Chlorine is a 1 negative charge, so we need 1 hydrogen there. Okay, so once again, chlorine 1 negative, 1 hydrogen balances out. This is an acid, so it is aqueous. Next, we have calcium carbonate. So calcium is a 2+, carbonate is CO3 2 negative. Those two cancels each other out and we get CaCO3. Okay, looking at my chart here for carbonate, KCO3, and it's mixing with calcium, so it's not an alkali ion. It's none of these here, so it's all others, so it should be a solid. Now, if you don't remember, oh wait, calcium, or if you don't remember, oh wait, a carbonate does this or a hydroxide does that, all you need to remember is just to do your double displacement. So hydrogen is switching with calcium. So hydrogen is going to go with the carbonate, calcium goes with the chlorine. If you remember that, everything should work itself out. Okay, so the first one I have calcium and chlorine. Calcium's a 2+, chlorine's a 1 negative. So after I do that crisscross, I'd get CaCl2. Okay, this here is an aqueous. Once again, you can look at your chart. And the next thing we have here is we have hydrogen switching with, or hydrogen coming with carbonate. So hydrogen is a 1+, carbonate is a 2 negative. when we do that crisscross, we get H2CO3. And if you look at your chart with carbonate, you would see that hydrogen is an alkali ion, or actually it's right beside it anyway. Sorry if I have the sheet here. Okay, it isn't part of that alkali family, but hydrogen is there, so it's soluble. Okay, now by looking at this reaction, you might think to yourself, oh wait, no reaction happens. However, you need to remember this one here, carbonic acid. And that was the one I said that's the most common one that we're going to be seeing. And what you need to remember is that this decomposes into carbon dioxide and water. This is the one that we looked at in our production of gas. So we're going to finish this off here. We have HCl, which is an aqueous. We have calcium carbonate, which is a solid. So we'd get our CaCl2. That doesn't change. However, this will decompose into water and carbon dioxide. So that's why this type of example is in both a production of gas because we're making carbon dioxide, and it's also in neutralization because we're also making a liquid. So it overlaps on both of them there. Okay, so that is our last example of what we have here. Okay, so once again, just to recap, okay, no reaction if you have two aqueuses. If you have a solid being produced, that's a precipitate. Once you get your gas being produced, it's a production of gas. And then lastly, we have two types of neutralization reactions there. Okay, so thank you for watching and have a good day.